All right, so I think this is recording. This problem number 10 is a challenging problem because the number of transformations that we have, it is very important that we perform these in the correct sequence. You can search the internet and you can find different sequences that work, but not every sequence will work. In our notes, we have that we're going to do horizontal shifts left and right first. Then we're going to do horizontal compressions, which means horizontal shrinks or horizontal stretches. And we also include a reflection across the y-axis in that step. So those first two steps are steps that affect the domain. Then the last two steps in order, we'll do vertical compressions, which means vertical stretches or vertical shrinks, and we'll also include reflections across the x-axis in that step 3. In step 4, we'll do our vertical shifts up or down, and you have those in the notes. Let's take a look then at this problem number 10. The first thing that we have to do is inside the parentheses, we do not want it to be in factored form. Like I've mentioned, there are sequences where you actually start with it being in factored form. So the first thing I need to do is distribute that 2 and have 2x plus 2. So I need to look at this problem as the parent function f is given here, and then through a sequence of transformations, we're going to end up with the graph of g. My outline here, I've pre-made some of these slides and stuff just to save time on the video. We need to do the horizontal shifts left and right first. The plus 2, it's bizarre in its behavior. It's actually a shift to the left 2 units. So that original parent function is going to shift to the left 2 units. Then we'll be working with a new table, a new graph, and this coefficient of 2, even though it says to multiply by 2, it's bizarre in its behavior because it's affecting the domain, and it's actually going to be a horizontal shrink by a factor of 1/2. Those are the two transformations that are affecting the domain, that are affecting the x-coordinate. They're inside the parentheses in our function notation. If we go outside now, we're affecting the output of the function. And if we look at this 1/2, ignoring that negative sign for just a moment, if we look at that 1/2, that's going to be a vertical shrink by a factor of 1/2. Outside of the parentheses, it's normal in its behavior. If you multiply by 1/2, you would expect something you expect to divide by 2. The negative sign on the outside of the parentheses, when you're affecting the y-coordinates, the output of the function, that's going to be a reflection across the x-axis. And then finally, this -1 is going to shift it down 1 unit. So this is almost the maximum number of transformations we have. Really, the only thing that we would be missing would be a reflection across the y-axis, and then that's the maximum that we could have. So this is a difficult problem. So let's attack it one at a time. Let's look at this original table. It's going to take me several sequences to get to my final table. So what's on that worksheet, that final table for G, you've got a lot of scratch work to do, a lot of work in between there to get to that final table. So when I look at this, the first thing I want to do is recognize that f is the parent function, so I'm using this original table. And then I'm going to do the shifts left or right. The plus 2 is to the left, and moving to the left is going to change the x-coordinates. It's not going to change the output, the y-coordinate. So this resulting graph, this new graph, I'm going to call it G1. And the y-coordinates are going to stay the same, 4, 3, 0, and -1. And although it says to add 2, I'm actually subtracting 2 from each of these x-coordinates. So I'm have -4, -2, -1, and 1. Now, it's these we now are going to work with this table. So when we come to our next transformation, we have this -4 4, -2, 3, -1, 0, 1, -1. See, that's the same table. I just went ahead and wrote it off camera to prepare for this. So now I'm working with this table, and I'm on to my second transformation, and I'm working from the first graph that we get from G1. So how am I going to move on to the second graph? I'm going to look at this coefficient of 2 and recognize to obtain this graph of G2, I'm going to horizontally shrink the graph of G1 by a factor of 1/2. So again, since we're inside the parentheses, the y coordinates haven't changed yet. 4, 3, 0, -1. And although it says to multiply by 2, it's bizarre in its behavior. We're actually going to divide all of these x coordinates by 2. -2, -1, -1/2, and +1/2. So now I have a new graph and I'm working with it. So on this next slide, those coordinates, I work with this graph. And the next transformation, well, I'm done with the transformations inside the parentheses. This column of x is now going to stay the same for the rest of the problem. This column of x is going to be in my final answer on my answer sheet. These y values are now going to change. The first change I'm going to do is a vertical shrink by a factor of 1/2. So these x coordinates now stay the same. And these y coordinates, I divide all of them by 2. So 4 divided by 2, 3 divided by 2, 0 divided by 2, and -1 divided by 2. And now this is the new graph that I'm working from. See these graphs, that it all builds upon each other. So in my next slide, I'm working with this table. So I've already written those values here. And now, let's double check and make sure they're the same. 2, 3. And they're not. I have made a mistake. This guy I want to be right here. Alright, so when I was making up the slides off camera, I meant to take this table and copy it exactly on the next slide, and apparently I had the wrong values, because when I went to the next slide it looked a little bit different to me. So I paused the video and corrected that. Alright, so now this table for G3 should be the same as this table for G3. I've just copied and pasted it over here. Now moving on, that I have this G3, and I'm moving on to the next transformation, which is the negative sign, and it's a reflection across the x-axis. A reflection across the x-axis is going to change the sign of the y-coordinates. What was up is now down, and what was down is now up if you've reflected across the x-axis. So these x-coordinates, like we mentioned before, they're staying the same. When we're doing these transformations outside of the parentheses, it's not affecting the x-coordinates. These new y-coordinates now simply change sign. The +2 becomes -2, and so on. So now we're ready for our final transformation, and that's going to be to shift the previous graph, this G4, down 1 unit, so my x's stay the same. And all of these being shifted down, I subtract 1. It's normal in its behavior. It's not bizarre. It says subtract 1, and that's exactly what I'm going to do. If I subtract 1 there, it'll be -5/2. If I subtract 1 there, -3/2. So this is going to be our final graph that we plot. And let's go to that Desmos graphing calculator, and I'll show you how I did each of the graph, each table and the graph of each table. You want to be careful, and maybe I should have given you several blank graphs to kind of build your final graph, because it can get sloppy if you're doing everything on the same graph. So it did take me the very first time I used this Desmos graphing calculator to define things piecewise. It took me a little bit of time and effort to figure out how to do it. This first value, x being between 1 and 3, is telling me to draw this portion of the graph, and that portion of the graph was just a line with a slope of -1/2. And if you use the point 1 0 and the point 3 -1, you come up with that equation. So I did that for each line segment, and it's not really important that you understand this piecewise notation yet on this graphing calculator, and you can get by with not knowing it for the whole course. But some people may want to explore that, so you can pause the video and look and determine how to build your own piecewise function. If you go up to this edit list, you can duplicate it and you can convert this to a table, and you can see then that this table is just the original points that I had on that first function. Now I thought that when I toggled that off, I really was expecting just to see the points. I didn't think that it connected the dots, but apparently it does. Alright. The whole reason I just wanted to include the table is in our notes and explanation is to show how the table changes with each transformation. So with this first transformation, that +2, you can see it's going to be a shift to the left 2 units, and I've included the table here, and you can see the x coordinates changed, but the y coordinates from the previous table remain the same. And that's what I've written in the notes here. If you come up and hit this menu and you select that notes, then you can type notes to yourself as you're building your library of functions. That you can create your own account on this Desmos graphing calculator. It's free. There's no pop-up ads. If you don't use it very much this year, definitely bookmark it, because next year in calculus or a couple years from now in college, it's going to be nice for you to have a graphing calculator that's free if you have internet access somewhere. Alright, so I'm going to toggle the original one off, because now we're working with this graph, and what we want to do is the next transformation, which is that 2, and that is a horizontal shrink by a factor of 1/2. It's bizarre in its behavior, and you're going to see these values shrinking and getting being drawn in closer to the y-axis. This point that had an x-coordinate of -4, you divided it by 2 and it became a -2. Over here, this x-coordinate of 1 became 1/2. So the graph was horizontally shrunk and compressed towards the middle, with the middle being the y-axis. So then we work with that graph. Okay. And we're done with the horizontal changes. Now the changes are going to be vertical. They're going to be affecting the y-coordinate. You're going to see this column of x's remain the same for the rest of the problem. So if we go up now, we could do the 1/2 or the -1 that's in front. Within that step, it's interchangeable. But I'm going to do the 1/2 first, which is going to be a vertical shrink by a factor of 1/2. These y-coordinates are going to be vertically shrunk closer to the x-axis. You can see how it squeezed down. This had a height of 4 units above the x-axis. Well, it shrunk, and now it's only 2 units above the yeah. Now let's turn off the previous one. It's hard for me to I don't think I'm colorblind, but boy, those look very similar shading. Alright, so now I have this graph that resulted from the previous graph of vertical shrink by a factor of 1/2, and now I'm going to reflect this across the x-axis. So this negative sign, what was up is now down, and you can see that the upper part, the part that was above the x-axis, is now below the x-axis. Then we have one final transformation to do, and that's to push this down 1 unit. And we do that, and there is our final graph. And here's that final table that's illustrating the endpoints of these line segments. So that's the final answer that you have on your worksheet. And like I say, I apologize. I probably should have given several blank graphs and several blank tables to kind of build up to this answer. So this is definitely the toughest one on the homework assignment. It's going to take some time and effort to understand this one, and you'll have a lot of practice building these. Probably I was a little premature in giving you this difficult of a problem so soon, but hey, it's kind of your future, your crystal ball of what's to come. So I hope this helps, and I'll talk to you later.